These are your 7.5B notes on solving logarithmic equations using properties. We're going to use the same properties we already went over. We're going to use the reverse one. So if we see it expanded where there's 2 logs, we actually want to create 1 log. So actually, they're going to show us addition, subtraction, or multiplication of logarithms, and then we're going to condense it into multiplication, division, or power. So it's kind of the reverse way of using these properties. So just really quick, we're going to go through all of the tools we have to solve logarithmic equations. So the first one is the product property. And the product property basically says, this is the one we're going to use. If you have log base b of m and you are adding it to log base b of n, we can condense that into 1 log base b of mn. So backwards. They're going to give us the addition where there's 2 of them and we want to make it into 1 log. Quotient, if log base b of m subtract log base b of n, we're going to condense that into log base b of m over n. And then the power property, if I have a number p times log base b of m, I'm going to rewrite that as log base b of m to the p power. So if it's multiplication, I'm going to change it into a power. The other 2 properties or tools that we're going to use to solve involve the property of equality. Okay, there's several different properties of equality. So one of the properties of equality is if you got a base to some power x and it's equal to the same base to the power of y, or we could use the power property of equality if you have a log base b of x and it's set equal to the log base b of y, then we can assume that x equals y. So that power property of equality is really saying you can eliminate the bases and set the exponents equal to each other, or you can eliminate the logs themselves and set the thing that they're taking the log of equal to each other. That's a property of equality. So remember, we use that if we have common bases, or we use that if we have a log on both sides. The other tool we use is what's called the definition of a logarithm. And this one is if we have log base b of x equals y. This is how we eliminate the log using exponential form. So this is where we take the log, we eliminate the log by rewriting it as x is equal to b to the y. So you change it into that exponential form. You have to check your answers. Okay, x must be a positive value, so you always have to look to make sure that it's positive. And sometimes extraneous solutions may occur, so you always have to check them. It's not optional. All right, so let's go ahead. So we're still solving logarithms. We already did a day of this, but the logarithms we solved earlier were a little bit more simplified. So if you look at what we got going on here, there's a couple things. There's a 4 out in front being multiplied, and there's a subtraction. I cannot solve this until I have a matching log on both sides. I can already tell I'm going to use the property of equality where we eliminate the base from each side, but there's 2 logs on one side and only 1 log on the other. You cannot cross off 2 on one if you don't have it on the other. And in fact, you can't do that. You have to condense them. You can only eliminate 1 log equal to another log. So even if there were 2 on the other side, you can't cross them all off. So what I can do is I can condense what they're saying there. I can make this 4 that's being multiplied by the log base 2 of x go up here with the x up here. And I'm going to change the subtraction into a division problem. So I'm going to condense this log base 2 into 1 log base 2. So log base 2 of x to the 4th over 5. Remember, it means division. Subtraction is division. And what I just did there is I took 2 log base 2's and made them into 1. And that is equivalent to log base 2 of 125. Now I can eliminate the log from both sides. Log base 2 is gone. So x to the fourth over 5 is equal to 125. And now just use inverse operations. Okay, look at the variable. Whenever you solve, you're trying to get the x by itself. Right now, x is being taken to the fourth power, and it's being divided by 5. So inverse operations tells me I need to multiply by 5. X to the fourth is equal to 625, and then take the fourth root. And so x is equal to, when I take the fourth root of 625, it's really plus or minus 5. Can't have the negative value, so I'm actually going to just use 5. When I plug them into that variable up in there, I can't have a negative 5. So I eliminated negative 5, and my solution is 5. Okay, the second example here, I've got to condense these two log base 8s. They're being added, so I can actually change that to multiplication. So addition is the same thing as multiplication. So when I change it to multiplication, I'll only have one log base 8. So it's going to be log base 8 of x times x minus 12. And that's equal to 2. I can see that I only have one log on the left side, no logs on the other. So I will eventually have to write this as an exponential. But I'm going to clean it up first. So log base 8 of x squared minus 12x is equal to 2. This whole thing is my x value. And so now I'm going to change it to an exponential. My x value is equal to the base 8 squared. I'll clean that up. X squared minus 12x equals 64. I have something squared, so I'm going to have to use factoring to solve. I'm going to bring over with 64, get it equal to 0. You could factor or use the quadratic formula, either one. You ask yourself what multiplies to give me negative 64 and adds to give me negative 12. And the answer is, I can't think. I don't know why this one's so hard for me. Give me 1 second. I'm going to grab my calculator. I feel like 16 and 4. Does that work? Yeah. 16 times 4. I don't know why I couldn't figure that out. So we're going to do minus 16 and plus 4. So x minus 16 equals 0. X plus 4 equals 0. X equals 16. And x equals negative 4. When I go to plug them in, I got to look and see if they work. I get x is 16 works in both cases. It gives me positive values, but the negative 4 would not work. So my solution here is just 16. All right. This next one, we've got a couple things going on here. We got subtraction, which means division, and we got the power. So what this one's going to become is log base 5 of x cubed over 4 is equal to log base 5 of 16. And we just continue the same way. We'd go through the logs, multiply by 4, and then take the cube root. I'm not going to finish that one off just for time. I think you guys got it. So for the lesson summary, what I'd like you to do is I want you to use the power property to rewrite the following log expression as a power. So convert that to what it would look like as a power. And I want you to solve this equation. Good luck.